Hi, this is the video lesson for Form 5 Physics Chapter 2, 2.2 Atmospheric Pressure. Okay, I'm going to discuss question 3 onwards. Okay, so let's see question 3. Diagram 2.1 show a glass filled to the top with water. That means fully filled. The glass is fully filled with water and covered with a piece of cardboard. You cover first and then invert it, terbalikkan dia, and then you try to pull up, lifting. Diagram 2.2 show a glass filled to the top with water and inverted with a water filled container. In both diagram you can see after you invert them and then you try to lift up the glass, the cardboard and the container also lifted up. Okay, first question. Name the physics concept involved. Okay, so the physics concept involved here is first of all, what is physics concept? Physics concept is like the subtopic name lah. Right. For this is atmospheric pressure, so we name it as atmospheric pressure. Second question. B. Observe diagram 2.1 and 2.2. State the similarities between the situation of the glasses. In 2.1 and 2.2, what we can see similarities. Okay. In both diagram, when you pull up the water, pull up the glass or lifting the glass, both the cardboard and container also lifted up together with the glass, okay, due to atmospheric pressure lah. Right, so similarities. Okay, in both diagram, the cardboard and container is lifted up together with the glass. Okay, why this happened? Okay, let's see why this happened. Okay, if you see the cardboard and then you have the water fully filled with water, so this water got weight, but your atmospheric pressure is so strong that can support the weight or overcome the weight. So the atmospheric pressure is much stronger, preventing the cardboard or the container from falling down lah, right? So we explain that in words. Okay, the atmospheric pressure from the bottom of atmospheric pressure from the bottom of cardboard, right? Cardboard and container is strong enough to overcome the weight of the water in the glass. Hence, the cardboard or container will not fall down lah. All right. Next question. Name two applications that uses the concept of physics stated in 2b. Actually 2a, not 2b. Atmospheric pressure. So what are the things that using atmospheric pressure? This is all. Atmospheric pressure is actually you learned already. Science Form 2 Chapter 8. Okay. Right. Example vacuum cleaner. And then you have a straw, siphon, and what else? Rubber plunger, rubber sucker. Okay. and so on lah. Okay, anything that is related with your atmospheric pressure will be accepted here. Okay, next question. Question 4. Okay, question 4. They show you a YouTube containing mercury, and then they are using the same liquid. If different liquid is will be much complicated, but we are using both end of the YouTube is mercury, and but then they are not equal in length. So let's investigate about this. Oh, they're not equal length because this is open end. Okay, this is open end. So here only the atmospheric pressure will acting. Okay, that pushes this. Actually, it should be balanced like this, right, initially. But when you have atmospheric pressure, it will push up the mercury. That's why we have a difference here. Okay, what is the pressure acting on point X and Y on the surface of the mercury? Surface of the mercury. That means what is the pressure acting here? What is the pressure acting here? So you see here it is open end, so atmospheric pressure will acting on your PATM lah. Okay, here it is vacuum. Can you see vacuum? Vacuum means no air particles. Then how you going to exert the pressure? So so the correct answer should be 0 here. 0 Pascal. So what is the pressure acting? I'm not so sure they asking the value or what. Okay, in case lah, atmospheric pressure means you just write 756 millimeter Hg lah. Okay, this is 0 Pascal or millimeter per Hg. Or just mention at 0 is enough already. Okay. You want to write like this also can. But 1 second. I don't think so you need this. Okay. Just slash the millimeter mercury. By comparing the pressure at point X and Z, explain why the height of the mercury column is a measure of atmospheric pressure. Okay, that means they're asking why this should be the atmospheric pressure. Okay, so let's look at here. You can see the point X and point Z are equal, right? Equal level. So actually the pressure X is equal to pressure Z, you know. Okay, so if and remember your pressure, the pressure at X is actually the atmospheric pressure, and uh, also for the pressure at Z pula, kita tengok dari atas. Okay, kejap, let me clear this. Okay, once again, X and Y is the same level, right? Okay, level. Actually, you can use this as a point to explain, but let me see. Let me explain first. Level at the X is equal to level at the Z, right? Okay, so that means pressure X should be equal to pressure Z. And we know that pressure from the question A, pressure X is actually atmospheric pressure, while your pressure Z is here you have 0, and here you have H centimeter Hg uh, as your pressure lah. So I can write like this lah, pressure due to what this one, mercury column. Pressure due to mercury column, and then you plus with 0 at the vacuum there, top there. So you see pressure X and pressure Z are equal, right, previously. That means your atmospheric pressure should be pressure due to mercury column plus 0 is nothing lah. So atmospheric pressure is pressure due to your mercury column, which is equal to 756 centimeter Hg. This part, is, remember, this is what I call as a pressure due to mercury column. Okay, it's like this, guys. Okay, you want to think in a atmosphere. Pressure of X, equation number 1. Pressure of Z, equation number 2. So both are equal, right? So that means the atmospheric pressure should be equal to pressure due to mercury column. Pressure due to mercury column is 756 centimeter Hg. Okay, so that's therefore your H is the atmospheric pressure. We can make a conclusion there. Okay, but we need to explain by comparing X and Z. Explain why height of pressure column, sorry, height of mercury column H is measure of atmospheric pressure. Okay, first point. Since, okay, whatever I gave here, I just write down. Since level X and level Z are the same, the pressure acting at X, which I name as Px, I give the name, is equal to pressure acting at Z, that is pressure of Z. Okay, right, first point done. Second point, pressure X, you also can write like this, doesn't matter. Pressure at X equal to atmospheric pressure. While that's why I introduced first in the point number 1, Px. Okay, pressure acting at X. Pressure ATM is equal to pressure X, while pressure Z is equal to pressure due to pressure due to mercury column. Mercury column, they already tell us is the height, right? So I put the H lah, pressure of H plus 0. Okay, so comparing, not combining lah, comparing pressure X and pressure Z, comma, pressure atmospheric is equal to pressure due to height of mercury column. Okay, this height is actually, okay, better for me to write like this lah. I just tackle lah, sometimes your teacher won't understand. Due to mercury column plus 0. So pressure atmospheric is equal to pressure due to mercury column which is equal to pressure of H. So therefore your H is actually equal to pressure of atmospheric pressure. Okay, hope you understand this. Next, determine the atmospheric pressure in Pascal. Common question. So we know it's a 756 millimeter. Okay, we write first. Pressure equal to rho Hg. Pascal means you need to use this formula. And remember, your atmospheric pressure is 756 millimeter Hg. So it is given that the density of the mercury is 13,600 and the G is 9.81. Okay. Density 13,600. Height of the mercury column. Make sure everything SI unit. So 756. You don't think divide 100, divide 1000, that one all no need. You see the milli. What is the value of milli? Times 10 to the power of -3. The meter you kekal lah. Okay, and the G is 9.81. So you should be getting 13,600 times 9.81 times 756 power negative 3. Let me bracket this. We're getting roughly 101,00862.496. Okay, so you can simplify this thing or not. Okay, let me see. Just express it in a standard form lah. If you want to express this way also can, Pascal. Okay, but then this one too much decimal place lah. If you feel so, then use your what do you call standard form. Okay, 1.01 times 10 to the power of, okay, 1 2 3 1 2 3 4 5 Pascal. Okay, also can, no problem with that. Okay, let's see question. Next question. Oh, still got making decision. Okay, right. It's regarding sphygmomanometer. Sphygmomanometer. Okay, they show 3 sphygmomanometer PQR used to measure the patient's blood. Okay, they give the specification here. First one is the pumping bulb, got elastic and inelastic, and then inflatable cuff. Oh, both also, all of them are inflatable cuff. And then, but then the material is different. It's a nylon and a cotton is there. And then we have a release valve at both diagram Q and R, but then in P don't have. Okay, from this, can we make the best decision or not? Okay, let us see. Based on diagram 1.1, state the characteristic of sphygmomanometer that can measure the blood pressure effectively. Okay, pumping bulb. Okay, pumping bulb, you see, yeah, the specification should be inelastic or elastic. Definitely it should be elastic. Inelastic means how you're going to pump the blood. Okay, so it must be elastic. Okay, so reason, easy to pump. Simple as that. Easy to pump, or you also can tell can pump continuously. If inelastic means you cannot pump continuously. Okay, second part. Material used for the inflatable cuff. Okay, we have a cotton and nylon. Okay, of course we use nylon. Okay, nylon is basically is a very strong material, very strong. Okay, so we can say stronger. If it is a stronger material, it must be durable. Okay, not easy to tear. Anything logical. And then if it is a nylon, if it's cotton, wait. If it is a cotton, it is very hard. Once you get dirty, it cannot be cleaned easily. If nylon means just nylon is not so sticky, you can just remove the dirt easily. But cotton is the thing is it will absorb. So nylon is easy to clean. So anything logical we accept. Okay, not necessarily must related to the topic. Okay, anything logical is acceptable. Component to release the pressure. Component to release pressure, we have a release valve screw. Okay, equipped with release valve screw. Okay, normally why we have release valve? We already learned in the Pascal principle. We want to return to its original condition easily. Just one push, come original ready. Okay, so whatever the mercury rise up to measure the blood pressure, After you press the release valve, it will return to its normal condition lah. So reason is easily so no how to tell, the mercury easily flow back to its original position. And third one, determine the most suitable sigma 4 manometer design that can measure the blood pressure effectively. Okay, of course, let's see. We can, of course, we can make decision through our reason here. It must be elastic, nylon, and have the release screw valve. So here don't have the release screw valve, so we don't want to choose P. Between Q and R, this R got cotton, we don't want, so we choose the Q. Okay, right. Next question. Question 5. Easy question. Okay, diagram 5 show an Android barometer placed at P and Q. Okay, remember when the altitude is higher, the pressure is lower. And when your altitude is lower, the pressure is higher. So because more air molecules at the bottom there compared to the top. You also can explain in terms of density, temperature, so much things. Okay. Right, compare the reading between barometer P and Q. Okay, you see the diagram and tell us. Okay, of course at P is higher, right? So the reading of the reading of barometer P is higher than Q. Okay, I make P as a subject. So compare the altitude of P and Q. So P is lower, right? So the altitude of P is lower than Q. State the relationship between the reading of the barometer and the altitude. Okay, careful, you don't see this one is first, so you want to tell a reading of barometer first. Must see first which one is manipulated. We control the altitude and the result is the reading. So your manipulated altitude, your responding is reading. So explain your altitude first. Don't get tricked by the question. Okay, so lower the altitude, of the mountain, higher the reading of barometer. Next question. State the relationship between the atmospheric pressure and altitude. Same question. Just replace the reading of barometer. Reading of barometer is actually measuring the atmospheric pressure. So lower the altitude of mountain, higher the reading of atmospheric pressure. All right. That's a rather easy question. Okay, I think we still have a few more. Explain your answer. You need to explain your answer. Why, when the altitude is higher, your barometer reading is lower, or when your altitude is lower, why the barometer reading is higher. Okay, so I hope you still remember about this. You need to tell the air molecules at the top of the mountain is lower, okay, or at the lower altitude there is more air molecules, so they will rate of collision will be higher, then the air molecule will move slower. That's why atmospheric pressure is lower, or vice versa, anything. Okay, right, so let's see here. First one. Okay, lower altitude, at lower altitude So at lower altitude, what will happen? More air molecules are there due to the gravitational attraction lah. Okay, more air molecules more air molecules more air molecules present, okay, due to uh, attraction force of gravity. Second point. So what else you can tell? At lower altitude, more air molecules present due to attraction force of gravity. So the rate of collision between the air molecules increases. Rate is higher lah, higher, and air molecules move faster. This causes the atmospheric pressure is higher. Sometimes some book they explain due to temperature and density of the air molecule also can, but that one is last time KBSM we used to do that. But in our latest textbook they expecting something like this. Okay, even in KBSM you learn in your science it's somewhere like this. Okay, you can explain in many terms lah, depends on your teacher, and this is not wrong. Okay, and then the next part. Okay, the next part, diagram 1, figure 1 show the apparatus for comparing the density of two type of liquid after some air is sucked out of the apparatus. Okay, you suck out the air and become the liquid X become 36 centimeter, your water become 35 centimeter, and the question, why the pressure at point A and B equal to the, sorry, point A is equal to pressure at point B. Okay, observe the point A and B. So if you calculate this will be, some air only sucked out. So this is actually gas pressure already. But at point A, it's you know, the atmospheric pressure is acting on the surface of the water, right? So that's why A and B should having the same pressure because both also atmospheric pressure. Okay, at the same level, right? Somehow they are in the same level. Okay, although the density of although the liquid is different. Okay, so what you can tell is A and B are at the same level in a stationary liquid. Okay, A and B are at the same level in a stationary liquid, so the atmospheric pressure at A and B should be the same. Okay, therefore calculate the density of liquid X. Okay, this one we know already at point A and B are the same, right? So the raw one H1 G should be equal to raw 2 H2 G. Same pressure. So the G and G cut. So the density of water is 1000 and the height of the water is 35 centimeter. So 35 centimeter is 0.35 meter, or you also can write 35 times 10 to the power of negative 2 centimeter. Okay, and then for here the density of liquid X is what we're going to find. So make it rho 2 H2. Height is 36 centimeter. So 0.36 meter. So your rho 2 should be 1000 multiply 0.35 divided by 0.36, and you will get around 972. Okay, density ingat dia punya unit kilogram per meter cube. Alright, that will do that. Okay, next question. Final question, essay question. Okay, question 1. Figure diagram 1.1 show the position P and Q at a different altitude. Two identical simple parameters is put at both positions. The height of the mercury column is shown in the 8.2. At P, the mercury column, is it same? Let me check. No. At P is this higher and Q is lower. Okay. What is the meaning of density? Okay, density is mass per unit volume. Next question. By using diagram 8.1 and 8.2, compare the altitude. Okay, first point. Compare the altitude surrounding air density, height of the mercury column in the simple barometer of position P and Q. So, got 3 points, so 3 marks. So, first one, you need to tell about the altitude. Okay. Q is higher. So, altitude at Q is higher than P. You can write in point form, doesn't matter. Okay. And then air density. Okay. Di sini udara kurang. Di sini udara banyak. So, density dia dekat P lah yang lebih banyak. Okay, Q is lesser lah. But you can write less lah. So, density, surrounding air density. So, density of surrounding air at Q is lower than P. And atmospheric pressure, no. Height of the mercury column. Okay. Height of the mercury column in simple, I just copy back whatever they gave us, barometer at position Q is lower than P. Okay, straightforward question. Okay, now relationship. Relationship question between the altitude and the density. Okay, and the altitude and the atmospheric pressure. So, altitude is your manipulated variable. So, higher the altitude, lower the density of the air. Okay, atmospheric pressure. Actually, the lower the density of air, you also can do here. Just now explain one. Lower the altitude, more the air molecule produced due to attraction force of gravity. Okay. So, the density of air is higher. You can add this point here. Valuable points. Okay. And then atmospheric pressure. Higher the altitude, lower the atmospheric pressure. Okay, next question, question D. Okay, diagram 8.3 show a dropper in the bottle. Okay, So but then they label everything in Malay, so this should be the dropper penitis, salur penitis, dropper tube. This is the liquid. Okay, so the question is, by using the knowledge of atmospheric pressure, explain how the liquid in the bottle, okay, can be sucked into the dropper. Explain to 4 marks, so you need 4 points. So basically they're asking the working principle of a dropper lah. Okay, so first you need to press at here, okay, and then what will happen, when you press here, the air inside the dropper lah, inside the dropper and the dropper tube will be sucked out, so it creating a low pressure area here. So the higher atmospheric pressure will push the liquid up, and then the liquid go inside the dropper tube lah, and then you can take out and use it. Okay, so basically that will be lah somehow more or less. Okay, so dropper is pressed, air is sucked out of the dropper and dropper tube. These create a low pressure region inside dropper tube. The higher atmospheric pressure that acting on liquid pushes the liquid into the dropper tube. More or less, you understand. You can create your own sentence and then explain this. Okay, right. Next, modifying, right? Section C essay lah. So we have a fan, hose, rod pemegang. Rod pemegang is handle rod, and then the dust here. Okay, you are required to give you suggestion to design a vacuum cleaner which can clean dust faster. Okay, see ya, you punya tugas, clean the dust faster and more efficient. So you need to give in terms of these 1, 2, 3, 4, 5 characteristic lah. Okay, first thing, what kind of material used for the body of the vacuum cleaner? Okay, vacuum cleaner is something you want to carry around, so it must be a low density material. So more efficient lah. But don't write more efficient, clean dust faster anywhere. That is the ultimate point. Okay, right, so it is lighter. Simple. And then the material used for the hose, elastic hose. Just now in the sphygmomanometer we already learned, right? So we need something elastic. Okay, why it need to be elastic so that it not easily break or tear lah. Simple as that. And then the size of the fan. Okay, size of the fan should be larger. A bigger fan lah. Why it should be bigger fan? Okay, you know, right, the working principle of the vacuum cleaner. When you on the vacuum, it will turn the fan and suck out all the air outside, creating a very low pressure area here. So the high pressure will push the dust together here. Okay, right, so bigger fan so that more air can be sucked. And then the fourth one, size of the floor nozzle. is floor nozzle? Floor nozzle is this part. Okay, it should be bigger so that more dust can be sucked. Sense, more common sense. Wider floor nozzle, more dust can be sucked. Okay, very sorry for my bad handwriting. I'm very sleepy today. It's 4:14 a.m. so that's why I'm rushing. Next is diameter of the handle rod. And diameter of the handle rod we want to be uh, here. Diameter of the okay. If you learn in your where we learn this Bernoulli principle kind, when it is a smaller pipe, the air move very fast one. When it's a bigger pipe, the air move very slow, right? You make use of this knowledge enough already. So the diameter should be smaller so air can flow very fast. Air with the dust lah. So diameter of the handle rod should be smaller. Okay. Why is it like that? So air with dust can move or can be sucked in. அப்படி வராது. Can air with dust can move down. Okay, air with dust can move with higher velocity. Okay, all right. So yeah, until there only. So I think I finished discussing all your 2.2 atmospheric pressure exercise. Upcoming is Archimedes and Bernoulli. Maybe tomorrow night I will do the Archimedes lah. Okay, and the following day I will do the Bernoulli. Okay, so please complete your 2.2 exercise and I want to check on the upcoming Saturday class. Okay, right, that's all. Thank you. Take care. Bye.